In this video, we are going to talk about the next section, text, sound, and images. So let's first look at the first part, which is about text. In the computer system, we use character sets to represent text, and we will talk about two character sets. The first one is the ASCII code. The ASCII code system was set up in 1963 for use in communication systems and computer systems. The standard ASCII code character set consists of 7-bit codes that represent the letters, numbers, and characters found on the standard keyboard, together with 32 control codes. You can see that the letter capital A refers to 65 in denary. The extant ASCII uses 8-bit codes, which gives another 128 codes to allow for characters in non-English alphabets and some graphical characters to be included. However, ASCII code does not represent characters in non-Western languages, for example, Chinese characters. For this reason, different methods of coding have been developed over the years, and one of them is called Unicode. Unicode can represent all languages of the world, thus supporting many of operating systems, search engines, and the internet browsers used globally. ASCII code uses 1 byte to represent a character, while Unicode will support up to 4 bytes per character. Next, we are going to talk about the representation of sound. Sound waves are vibrations in the air. The human ear senses these vibrations and interprets them as sound. Each sound wave has a frequency, wavelength, and amplitude. Sound waves vary continuously, which means that sound is analog. However, computers cannot work with analog data, so sound waves need to be sampled in order to be stored in a computer. Sampling means measuring the amplitude of the sound wave, and this is done using an analog to digital converter. To convert the analog data to digital, the sound waves are sampled at a regular time intervals. The amplitude of the sound cannot be measured precisely, so approximate values are stored. Increasing the number of possible values used to represent sound amplitude also increases the accuracy of the sample sound. The number of bits per sample is known as the sampling resolution, also known as the bit depth. The number of sound samples taken per second is known as the sampling rate, and is measured in hertz, where 1 hertz means 1 sample per second. Using a higher sampling rate or larger resolution will result in a more faithful representation of the original sound source. However, the higher the sampling rate or sampling resolution, the greater the file size. Then we are going to talk about the representation of images, and we will take bitmap for example. Bitmap images are made up of pixels. An image is made up of a two-dimensional matrix of pixels. Each pixel can be represented as a binary number, and so a bitmap image is stored in a computer as a series of binary numbers. The number of bits used to represent each color is called the color depth. For example, a black and white image only requires 1 bit per pixel. The number of pixels that make up an image is called the image resolution, and you can see from the picture that an image with a lower resolution will have less detail than an image with higher resolution, but higher resolution means larger file size. So what we have learned in this video is the character sets, which is ASCII code and Unicode, and also the representation of sounds and the representation of images. And in the next video, we are going to look at data storage and compression.